Most networks at home look something like this. You have your modem that is connected in some way to your ISP, and that is connected, the one port of your modem is connected to the one port of your router, and it using most likely DHCP generates IP addresses for all the devices that you have at home. So you may have started by having a laptop and a phone and tablets, and also adding, let's say, cameras for security, sprinkler system, printers, smart TVs, refrigerators, and other appliances. And the problem with many of these devices is that these devices have full TCP/IP stacks with apps running on top of those that most likely never get updated. Okay, and that's the problem, because we know that even the best software out there, people make mistakes. Mistakes get exploited and need to be fixed. Many of these never get fixed. So it might be, do you want to have the same devices coexisting where you have concern for privacy, like your photos or your banking or stuff that you have on your tablet? Most likely you don't want that. And particularly, I don't know if you remember that actually still active. It has a second, coming of the Mirai botnet, in which was used to compromise a bunch of cameras, and from the cameras launch denial of service and other attacks into parts of the corporate infrastructure. But the same can be happening at home. People might be looking at what you are doing, and do you trust that particular router that probably your ISP put in there? Don't you want to monitor what's happening in your network, who is doing what? If that is your concern, this video is for you. What we're going to be showing you in this video is a mechanism by adding a different router, one that is running pfSense, and more on that later. You're going to love this pfSense router. But basically, what we will be doing is segmenting or separating what we can call the traditional devices or network, the Wi-Fi where you have all these devices that they have been proliferating at your home, and designate another segment. We're going to call it OPT for optional. You'll see why in a second. That we are going to consider the secure environment for your devices, right? So the device we're going to be adding is a hardware called, the brand name is Netgate, and the model number is SG1100. It cost me around $150. I have no affiliation, no support, nothing to really do with these folks. But I like this hardware for several reasons. Not only because it runs pfSense, that's big on itself, because there are other devices that do run pfSense. In fact, you can even take an old computer and add additional ports using USB to Ethernet conversion and download pfSense and run it for it. I wouldn't recommend you doing that, because it's a lot of well, if you cannot afford the $150 for this router, then you can try that. But again, different ways of running pfSense. You can run it on a virtual system. But the easiest way is to buy, if you can afford the hardware to actually do that. But the other reason that I like it is that when we will be separating these two networks, more on this later, we are going to even have, just by doing that, more security on itself, and we'll show you why. But also, this device, the SG1100, is the first one that has a mechanism. So when you update the software, it comes digitally signed, and there is a hardware verification process in it to make sure that what you are getting comes from pfSense and nobody else. And that's what I like. So this can be manufactured in China, but when I download my update from pfSense, I know I'm getting the real code. We are also going to show you how we will define some firewall rules that will enable the traffic going here in this direction. So you can, from your phone, you can monitor your sprinklers or your cameras or whatever is it that you want to do, but the traffic in the way back is going to be blocked. So if any one of these devices gets compromised, and probably they will during their lifetime, they cannot be used against your secure devices. Subsequently, in this video series, we're going to be showing how you can get syslogs from pfSense and also even NetFlows from this router, and you will be able to send those to your free Curator CE instance that we will show you how you install and all that later. So you can monitor in more detail what is actually happening within your network. We also will be showing how you will increase your privacy by doing DNS over TLS, so there's secrecy, not even your ISP can see where is it that you are actually going. We'll show you how you can actually deploy an IPS, so have some snort rules, and even monitor who is going where with the Squid as a proxy. We will do that again. We're going to be putting a Netgate router, and we're going to be providing another Wi-Fi. This can be a mesh that you put new. This can be whatever routers and repeaters that you may have. There are multitude. I mean, this video is not going to go into detail of that, other than when you use a mesh. Particularly, I tried the Google Wi-Fi mesh, and if I don't do double NAT, I cannot add other devices, and that's a limitation of the Google Wi-Fi. Nothing to do with that. But you should try to deploy these in bridge mode, not in router or double NAT mode, because if you do double NAT, what happened is that the IP addresses that you will be looking at the logs from and the net flows, they're all going to be coming from that in one NAT IP, and you don't want that. For further monitoring, you want to make sure that every one of your devices has a unique IP that you can monitor from the logs and the net flows. So that's what bridge is recommended over double NAT. Also, we will start by getting into your whatever is your Wi-Fi that you have today, going in there, and do not configure it as a router but as a bridge. Your router is going to be the pfSense device, right? So this is going to be put in bridge mode, and what you'll do is that you will connect the one port of your modem to the one port, as you can see here, of your pfSense router, and then the LAN port you will connect to the one port of your existing Wi-Fi. And by just doing that in the default configuration, you will be able to start getting all these devices that exist in the traditional Wi-Fi to work again. They will probably have a different IP because this router will do a DHCP that probably will assign different addresses, but that shouldn't matter for your devices. So you have everything working just fine. Now, from any one of the computers, because everything's going to be in the traditional Wi-Fi until we split it, if you open a browser and you go to 192.168.1.1, then you're going to be presented with the interface to log in into pfSense. After you log in the first time, and the default user ID is admin, and the default password is pfSense, the software will encourage you to immediately replace that password to one more actually stronger than that, and you will be entering into the pfSense menu. You will not see these graphics. I added those by basically clicking in this plus sign, and then you are presented with a menu of widgets that you can actually put, and you can drag and drop them around and put them the way that you want them. So doing that, you'll have the same existing network. You still haven't segmented it, but actually you will start with better security, because the default settings of pfSense are actually pretty good. So the one interface is enabled by default, and it provides the DHCP, and more on that later, how you play with that. But notice that the one interface comes with these two settings by default. Block private network, those networks that are RFC 1918, like 10.10.10, 172.16, etc., 192.168. Those that are non-routable, as well as the loopback, those addresses cannot go from your network into your devices. The router will block them. But a caveat: there are some places in some countries in which the ISP, the address that it gives you, is not a public IP, it's one of these. If that is the case, you need to go in here and uncheck this, otherwise you will not be able to connect back to the ISP. And the other default rule that it has is that it blocks what are called bug-on network, which are IP addresses that are not being assigned by the IANA, right? So you save, if you make any change in here, you click here and save. And again, just by doing that, you have a much secure, or a more secure, let's say, network to begin with, and we have just started. So again, this device works with 3 ports. The one that is connected to the modem, the LAN, the one that is enabled by default, and that's where you can put your traditional network. And notice that it starts with the 192.168.1.1, and then there is the OPT, which you don't have configured by default. I already did this, and that's what is showing this thing on the right, that we are going to be enabling in a minute. And this is the optional that we are going to be using for the secure network, and we will assign to it 192.168.2.1 segment. Okay. And also, I'm obfuscating, I'm actually covering here my IP address at home. So again, you have your additional Wi-Fi that you're going to use for your secure network configured in breach mode, preferably over the double NAT for the reasons we explained before. And now we're going to go ahead and enable the OPT network, which is disabled by default. You do that by going here under interfaces and selecting OPT. And sometimes I don't do this in order not to reveal my public IP. So already in here, you need to click here, enable interface. This is going to be disabled by default. And here is what I specified, that the IP address is 192.168.2.1. And I put the, see that range of 24. And one thing I just realized, that when I wanted to do this, I actually placed a call and did a WebEx with my good friend and network guru, Leopoldo Lopez, also known as Polo. And he's the one who taught me all this, and I'm passing along some of his knowledge to you as well, right? So once you have enabled this, you click here and save, and the first part of enabling the optional network for the secure place has taken place. Now we need to do some DHCP settings. So if we go under services and then DHCP server, we actually, this should be enabled by default. This is the subnet that this is configured by default. Notice that there are 99 devices on the 192.168.1 network. And basically, unless you want to change something here, this should be your standard setting. And that's for the LAN. If you go here under System General Setup, I believe it is, here's what we define the DNS server we are using. And we decided to use Quad 9. You've seen videos that I've done on this before on Quad 9, and these are the two servers for for Quad 9. And the reason why we chose Quad 9 is we're going to be doing DNS over TLS later for privacy. And so we want to use a good DNS resolver that includes your security, because if you go to a malicious site, chances are that the DNS resolution for that malicious site will fail due to the protection that Quad 9 provides. Now, I forgot to mention that when you go to services and DHCP server, that I show you the LAN configuration, you have, when you have enabled the OPT, as we did in the step before, you have the OPT network. And you actually need to go here and specify that subnet, the range for DHCPs that you're going to have, and I also put 100 of those. So I put from 192.168 to 100. I didn't want to start with 0, and ends in 200. Okay, this is how you define that. Nothing else needs to be done here. You click Save, and you are done. We're almost done. What we need to do is specify the firewall rules that we are going to be using. So this is the one, and we didn't touch any of these. This is the protection that we referred to before. But if we go to the LAN, these are the default rules, except for this one that is marked with an X, which is blocking. Let me talk a little bit about this. The first rule is the one that allows us to go into 192.168.1.1 from any computer on the LAN network, which is the one that you initially have, and begin to log in into pfSense and work in it. After you finish with all this, you most likely will want to click in here into Actions, and notice that it takes you to Advanced Admin Settings, and there is a section in here that enables you to disable this anti-lockout in order to make sure that no device within your network, let's say that if anyone gets this compromise, can attempt to log in into the administration of your router, even if they were able to figure out your password. So for extra protection, you want to disable that one. Going back to the firewall rules, if we go to the LAN, well, that's actually where we were. This is, we talk an anti-lock rule. These rules are by default. Notice that these rules are any to any. That means within the LAN network, anything can talk to one another and can talk to the outside. And you don't want to really modify this unless you want to get more sophisticated later and say, well, my camera should not be talking to anybody but the outside. I don't want it to talk anymore. And we can do some more videos that show you how you play with that later. But for now, nothing you need to do. A little bit about this menu. Of course, the pencil is for editing any one of those rules. This is for copying this rule in case that you want to copy a rule from one network to another. This one disables the rule when you are doing testing, and this one deletes the rule. Also, the order in which the rules are put is very important, because if you have a very general rule that gets evaluated, it may shadow the one below, and that's why the order is important, and the performance of it. But again, when this consideration for corporate firewalls. For what we are doing in here, that's not too important. But if you want to change the order, if you want to add one rule above this one here or below, you select one button or the other. Now, let me talk about this particular rule that we put in here. This rule, let me actually edit it. It's going to be easier if I show you this from the edit rule. And again, of course, if you select any one of these, you can use this button of delete, save, move the map down, etc. So let's edit this rule for understanding why we put this one in here. Remember that we told you that we want to block in case that any one of your IoT devices get compromised or it cannot snoop or do anything in your secure network. But this is how we did it. The action is block, and the interface is LAN, is other IPv4s, any protocol. Okay, we don't want any type of connectivity. And here the source is the LAN net, the one where my IoTs or unsecure or traditional devices are, and the destination is the OPT, the optional network, which is the secure one. And this simple rule, you click here save, and that's the one that is going to block that. If you want to check that this is actually happening, you can download Zenmap, which is a free program that is actually a Nmap scanner, and then you can say, well, notice that right now I'm in the traditional network. It's called MEMDB. That's my traditional network. That's where all my devices reside. And from that network, I try to actually go to the secure network. So if I try to go into 192.168.2.0/24, I want to scan the whole thing. You don't want to do an instance scan, that takes too long. So if you do a quick scan, that's better. So if I did this correctly, when I do scan here, nothing is going to pass. Everything is going to be blocked because of that rule that we did. So as you see, nothing is happening. Now, let me cancel that scan. Let me actually switch to my OPT network. That is now enabled. And if I do a scan of the actual one network, let me actually go here and put the one and do a quick scan. I should be able to see my my scan progressing and detecting devices in the other network. And here they are. I mean, these are all the addresses of all the devices that I have in my IoT unsecure network. So it's working as expected. So you have segmented your networks at home. You are running a more secure environment. If any one of these devices will be compromised, you don't have to worry that much. And stay tuned for looking at how you can use QRadar to monitor what is it, who is going where, and what's happening within your network, and all the good things that we would be expecting to do in the future with the help of Leopoldo Aguirre.